All right, let's jump right in. We're going to tackle a question that's at the very heart of modern finance. In all the chaos of the stock market, is there a real signal hiding in the noise? And could a very special kind of AI be the key to finding it? Okay, so let's start with the big problem, right? Financial markets are just a complete fire hose of data. Prices, news, reports, it's a constant, never-ending sequence. How on earth do you even start to make sense of what's coming next? For a long time, we've kind of had two different ways of looking at this. On one hand, you've got the traditional models. Now, they're good at finding straight-line, linear relationships, basically assuming the future will look a lot like the past. But then on the other hand, you have deep learning, which promises to find those messy, complex, hidden patterns that the simpler models just can't see. So you might be thinking, what's really wrong with just looking at past prices? I mean, isn't the market a lot more complicated than that? You've hit the nail on the head. These models you see here, they're basically the classic toolkit for financial analysis. And while they all have different names, they're all built on one big assumption, that the relationships are fundamentally linear. They try to predict the future in what you could call a straight line. But what if the market just doesn't work that way? All right, so if the old models have their limits, how does deep learning handle this? Especially with data that unfolds over time, like a stock chart. This is where a really cool type of network comes into play, the recurrent neural network, or RNN for short. The best way to think about it is like reading a sentence. You have to remember the words at the beginning to understand the meaning at the end, right? Well, RNNs are built with these feedback loops that let them do the same thing with data by holding on to a sort of memory. So, how does this memory actually work? Well, it's pretty clever. The network basically passes a little note to itself from one moment to the next. When it sees today's price, it's not just seeing a single number in isolation. It's also reading that note from yesterday, which has a summary of everything that came before. That's how it builds and carries context forward. Okay, a network that remembers things? That sounds amazing, right? But is there a catch? What's the downside? And that right there is the million-dollar question. What happens when that note has to get passed along a really long chain of events, say hundreds or thousands of days of stock prices? The information can get warped, kind of like that game of telephone you played as a kid. And this leads to a really fundamental problem. See, for the network to learn, it sends a correction signal backward through time. But as that signal travels, it gets multiplied at every step. That means the signal can either shrink down to basically nothing, it vanishes, or it can get so big it blows up the whole system. It explodes. Either way, the network can't learn from things that happened a long time ago. Its long-term memory just isn't reliable. Okay, so the basic RNN has a memory issue. Big problem. So, how do we solve it? Well, you don't throw it out, you give it an upgrade, and that upgrade is called a long short-term memory network, or LSTM. It was literally designed to fix that vanishing and exploding gradient problem by giving the network a much more sophisticated memory system. And the solution is just brilliant. Instead of one simple memory pipeline, an LSTM cell has this whole control system with 3 gates. You've got a forget gate that intelligently throws away old, irrelevant info. Then an input gate decides what new information is important enough to keep. And finally, an output gate controls what actually gets used for the final prediction. It's like having a tiny, smart memory manager inside the network. All right, this all sounds fantastic on paper. But you know what matters? Does any of this actually work when it comes to predicting stocks in the real world? Well, lucky for us, some researchers decided to put this exact question to the test. The setup was pretty straightforward. They took 3 different models, the LSTM, a regular neural network, and a more traditional model called an SVM. They fed them all the same historical data for 50 big S&P 500 stocks. And the goal was simple but super important. Could they just predict if the stock was going to go up or down the next day? That's it. Success was just measured by its hit rate. And wow, the results, they really speak for themselves. The SVM model, it was better than a coin flip for only 21 of the 50 stocks. The standard neural net did a little better, 27. But then you look at the LSTM. A whopping 43 out of 50 stocks had a hit rate better than 50%. That's not just a small improvement, that's a huge leap in performance. But what does that actually mean for a portfolio? Well, when they simulated a trading strategy using these predictions, it actually generated consistently positive returns every day. A long-only strategy made about 0.14% daily on average, and a long-short one did even better. Now, it's a small edge, sure, and this is before trading costs, but it's a clear predictive edge nonetheless. So what's the big takeaway here? It seems like we're really moving from models that just look at a static snapshot in time to models that can actually learn the entire story the market is telling. LSTLs don't just see a single price, they see the context, the history, the narrative. And that leaves us with a really exciting question. What happens when we teach these models to read not just prices, but everything else that writes that story? Hey, if you enjoyed this breakdown and found it useful, do us a favor and hit that like button, share it with someone who might find it interesting, and subscribe so you don't miss the next one. Thanks for tuning in.